Here. Okay, Muntaha, welcome to Igcse Computer Science lesson. And remember, we have started chapter number 1, data representation.
Sir, we did chapter number 2. We didn't do chapter number 1.
Listen to me. We have to start from chapter number 1. And in the demonstration, we have completed the topic 1, that's called conversion. Binary to denary is done, and denary to binary, I think, is also done. What do you think?
So last time we did data packets. Chapter 2.
Okay, that's for demonstration, right? So we have to start from the beginning of the syllabus. That is our chapter number 1. What do you say?
Yeah, okay.
Okay. Tell me about your school. Which chapter you are doing in your school?
Chapter number 8.
Okay, you're on programming. Fine, no worries. We are going to start from chapter number 1. Remember, we have discussed this paper pattern.
Oh, yes, sir. Yeah.
Okay, great. So you remember all these things?
Yes.
Great. Okay. Now, starting from the chapter number 1, data representation. In data representation, we know that our computer bases on a language of binary. Binary means 0 and 1, right? So computer is a machine which only understand this language that's called binary or machine code, right? Okay, so this is very difficult for humans to understand. So humans are using some number systems in which they are going to convert binary into their understanding terms like decimal denary or hexadecimal system. So in number system, we are going to learn about the conversions of binary to denary, denary to binary, and so on. Right? Okay.
Yes.
Okay. Your voice is not clear. I think you're using some headphones or something.
Yes, sir, I'm using headphones.
Oh, yeah, that's a reason. Okay. Now, starting from the first number system, what do you see on the screen? The first number system is binary. What is the first number system? Tell me.
Binary.
Binary. Okay, binary is also called base 2. Why it is called base 2? Tell me. Because it have only 2 numbers, 0 and 1. Binary language is also called machine language. It is also called machine language. Why? Because zeros and 1 is purely a language of machine or computers. So this is a mother tongue of computer, you can say, right?
Yeah.
Great. Okay. Now, what is the next term? What is the next number system you see on my screen?
Hexadecimal.
No, it's decimal. That's called denary. Denary number system means base 10. Why they are called base 10? Because they have the numbers 0 till 9. So if you count on your finger, they are become 10. So 10 means denary, base 10. And the last is hexadecimal system. Hexadecimal system is called base 16. Hexadecimal system called base
16.
Yes. Why 16? Because it have the numbers 0 till 15, right? But
yes,
there is one unique thing in hexadecimal. The unique thing is 0 to 9 numbers are same like denary. But while the number starts from 10 till 15, they are being represented by alphabets. So 10 is represented by A, 11 is represented by B, 12 is represented by C, 13 is D, 14 is E, and finally 15 is F. So this is a unique thing about hexadecimal systems. Is that okay or not okay?
It's okay.
Did you got it or not?
I got it.
So take out your notebook, write down and heading of data representation chapter 1 and number systems and draw this chart. You have only 4 minutes. You need to draw everything, write everything. Your time starts now. Once you're done, you need to send me the picture of your work. Okay, now moving on. Are you there?
Yes.
Now starting the conversions. Conversion means we are going to convert the binary into different number systems. So the first number system is denary. Binary to denary. Base 2 to base 10. Is that okay?
Yes.
Okay, now you see on my screen, there is a question. Can you read that question for me?
1100 1101
Perfect. This is a
2.
good question. So you can see there are the bits in ones and zeros because it is in binary. So the last bit you see on the screen is called LSB. That's called least significant bit. And the last bit is called MSB. That's called most significant bit, right? Least significant bit and most significant bit. Now we need to draw the registers. What are registers? Did you see this box? This box is called
Yes.
register. What it called? Register. What it called?
Register.
Registers. What are registers? Registers is a temporary area to store the data. What are registers?
Temporary area to store the
Perfect
numbers.
answer. So let me write it down for you. Registers. Registers are the temporary memory to store data, right? Okay.
Yes.
How many boxes I have drawn? Can you count these boxes?
8.
Why 8? Because in computer memory, 8 bits equal to 1 byte. So you need to consider that this is a 1 byte and we are going to store the data in 1 byte. So now I'm going to apply a numbering on it. Can you see this numbering? You need to always write down this number pattern on the 8-bit register. Please read it. 1, 2, come on.
4.
Yeah.
8. 16. 32. 64 and 128.
Perfect. It means these are the some specific pattern. Did you notice anything about this pattern? Any unique thing? You can see.
Powers of 2.
Yes, every number is a power of 2. That's great answer. Now you understand, while you see the answer question in a binary, you need to draw the registers, right? You need to draw the registers and put the numbering on it. 1, 2, 4, 8, 16, 32, 64, 128. Sometimes you got a big value. Like it is not mandatory that you always got an 8 bits. Sometimes you got 12 bits. Sometimes you got 13 bits. So you need to extend your register as per your requirement. So it can be extended like in this way. Look. So if you're extending the register like that, you need to also extend your values. So 128 doubles 256. 256 doubles 512. 512 doubles, tell me, 1024. So in this way, the bits and the power extended if you have a big value. Understand or not?
Understood.
That's great. Now, what we have to do next? Tell me. We need to write down the question into the registers. So 1, come on, tell me. 0, 0.
Oh, not 0, 1, 1, 0, 0, 1, 1, 0.
Oh, yes. Now, tell me what we have to do next. We
You
need
have to
add the numbers which are having 1 over it. So 128 have 1 plus 64 have 1 plus 8 plus 4 plus 1. Can you add it for me and tell me the answer?
So I got 205.
Sorry, 205. Look, our question that's in binary is now converted into denary. Understand or not?
Yeah.
Always remember, you need to draw the register. Always remember, you need to write down the numbering, and then you need to put the binary pattern in the box and count the values which are having 1. Like 128 have a 1, 64 have 1, 32 is 0, so we didn't count it. Take out your notebook, write down question number 1, write down everything which you see on my screen. You have only 3 minutes. Okay, what is our next question? Can you tell me?
Wait 100100101 into binary.
Yeah, so what we have to do first? Tell me the steps.
First, we place the values, the binary number into the boxes.
No, first we need to draw the register. Then we need to put the value over it. And then we are going to write down the numbers in it, right? So 1, 0, 0, 1, 0, 1, 0, 1. Now tell me the answer.
So we add all the ones. So
We
it
have
will be
128 plus 16 plus, you cannot use calculator, right? You need to do all things manually.
okay.
So 128 plus 16.
So that's
144, 148, 149 will be your answer. 149, right?
so I'm getting
Sorry?
145.
145 is the answer?
Yeah.
Okay. Okay, no, do not do anything, right? You need to just wait for the question. Like I will give you the time to write down. You need to just solve it with me. Okay, what is the next question you see on my screen? Can you just read it?
Okay.
Yes, please read it.
1100110010.
Perfect. How many bits are there? Can you count it for me? 1, 2, 4, 6, 8, 10. So how many registers we need to draw?
10.
10 registers. Great. Draw it in your notebook like that. Look. Okay, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. What is the next step we have to do?
If we label the registers,
Yes.
we double it each time. We go to the
Tell
left.
me the number. Can you remove your
1,
mic
2.
or headphone and you can come speak it directly because your voice is not clear.
Hello, can you hear me?
I can hear you, but your voice is like coming from too far. 64. Okay, look, 128. What do we have to do after 128?
128 times 2. So
What do we have to do after 128? Because we have 2 more numbers. Look, we have 10. Look, these 2 registers are left. So we need to double the value of 128. Tell me the answer. Look, every number is multiplied by 2. So 256. And then
512.
perfect answer. Very good answer, Munda. 512. That's a great answer. That's a great answer. Now, what is the next step we have to do?
We place the binary value into the register.
Okay, tell me. 1, 1, 0, 0,
0,
1,
1, 1, 0, 0,
1,
1, 0.
0, 0, 1, 0. Okay, now we are adding the values. So 512 plus 256 plus 32 plus 16 plus 2. What will be the answer? Calculate it and tell me. Do not calculate it on calculator. Calculator is not allowed in exams.
I got 880.
Sorry, 980,
818.
880.
18. 18.
Yeah, I told you I can't hear you properly. That's the problem. 818, right?
Yes.
Perfect. Okay. So now take out your notebook. You need to do these two questions. Question 2 and 3.
Okay.
You have only 2 minutes. Okay, now we have an activity 1.1. So I'm giving you this in your homework, right? So I have shared the homework in your WhatsApp group. So you have to attend any 3 questions of it. Any 3, right? Are you getting it
Okay.
or not? Yeah. Okay.
That's good.
Great. Now we are going to start the new topic. Can you just read the topic name for me? Denary to binary. Now we are going to convert the reverse. In the above topic, what we have done, binary to denary. Look. And now we are going to start denary to binary. Reverse. Is that okay? Okay.
Yes.
In denary to binary, the method is again same. Same method. What? We need to draw the register. What we need? We need to draw the register, right? Can you hear me now?
Yes, sir.
So why you're not responding to me? You have to be very punctual, right? Okay, tell me what we have to do. We need to draw the register. Is that okay?
Yes, sir.
Okay, great. After drawing the register, what is the next step?
We have to. Oh, yeah, we have to label the registration.
Yeah, 1, come on. 2,
2, 4, 8, 16, 32, 128. No,
no here.
64.
Yeah,
120.
perfect answer. Okay, now the thing is reversed. We need to see which numbers are added together to form 79. Which numbers are added together to form 79? So, can we take 128? No, because 128 is very big value. Can
Yes.
we take 64? Yes, 64 is smaller than 79. So I'm taking it, 1. Okay, can we take 32 with 64? Tell me if we are going to add, 64 plus 32, the answer will be what?
It
96.
would be.
So we cannot take 30.
Yes.
We cannot take 32. So I insert 0. Can we take 16 with 64? 16 plus
Oh,
64. Can we take? It becomes 80.
no, sir.
No, we can't. Can we take 8 with 64?
Yeah, yes.
Can you tell me the answer?
72.
Perfect. We take. Okay. Can we take 4 with 72?
Yeah,
What is the answer?
76.
Perfect. Can we take 2? 78.
Yes.
Can we take 1? 79.
Yes.
So look, our answer is now in binary form. Is that okay?
Yes, sir.
in this conversion, we need to use our mind and draw the calculation, do the calculation with the conversion. Because look, I do calculation bit by bit. So the same way you have to follow. Now we are going to move to the second question, right? Then I will give you the time to write it down. But you have to look at my screen first. Okay, can you tell me what is the next question?
569 do binary.
Oh, yeah. So what do we have to do first?
Draw the registers.
Perfect answer. So we draw the register, right? Okay. So can you tell me about the register? Okay, we have done it, right? Just a second, please. I need to delete it. Okay. Okay. Now tell me 169. How do we write 169? Can we take 128?
Yes.
Okay, okay, fine. Can we take 128 plus 64?
No.
0. Can we take 128 with 32?
Yeah.
Okay,
Yes.
what is the answer?
160.
160. That's perfect. So now our answer is very easy. Can we take 16? Quick.
No.
No. Can we take 8?
Yes.
And then what we have to do? We take 1. So look, it's become 169. So this is how you're going to do denary to binary. Is that okay?
Yes.
Any confusion?
No.
Okay. Take out your notebook, write down the heading of denary to binary, base 10 to base 2, and start writing these 2 questions. You have only 5 minutes. Okay. Now we have another question. The question is 421. Can you do it for me?
Yes, sir. In my notebook, sir?
Sorry?
Should I do it in my notebook or?
Yeah, you have to do it in your notebook, of course. Yeah. 421, right? This is a big value, so you have to be very careful.